Good morning to all. It gives me immense pleasure to introduce our chief guest, Mr.M.THIYAGARAJAN sir, Assistant Professor, the Department of EEE, Arasu Engineering College, Kumbakonam. He received his bachelor's degree in Electrical and Electronics Engineering from Arasu Engineering College, Anna University in the year of 2006. He did his master's degree in Power Electronics from Asst University in the year 2013. Presently pursuing his PhD in Electrical Engineering at Kalasalingam University, Madurai. Also, he completed his master's degree in Yoga for Human Excellence at Tamil Nadu Sports University in 2020. He has more than 15 years experience in both industries and teaching field. His area of interest includes electrical machines, power electronic converters, power systems, control systems, grid connected systems, power quality, and fax controllers. He has published 12 papers in international journals and presented 6 papers in international and national conferences. He is a reviewer of advances in science, technology, and engineering systems, Journal and International Journal of Creative Research Thoughts. He organized several technical events such as national and international conferences, faculty development programs, technical symposiums, etc. He was also acted as a resource person in webinars and faculty development program. He is a certified trainer in an international labor organization. He received for more funds in DST, ACTE, TNSCSP, CSIR, etc. He also acted as an NBA coordinator, NAC coordinator, placement coordinator, PMKVY coordinator and trainers, EDC coordinator, and TACO trainer. Finally, as a project coordinator, he was guided and published the 5 best student projects in various media. Thank you. Now, I hand over the session to our resource person. Welcome, sir.
Thank you, ma'am. Thank you. Good morning to every one of you. First of all, I would like to say my sincere thanks to our management and the principal of Arasu Polytechnic College and vice principal and HOD for given the wonderful opportunity to deliver my technical thoughts in the title of IoT applications in power sector. Good morning. Today, the IoT and artificial intelligence is the emerging technology in the recent years. There are a lot of research going on the ITs in artificial intelligence for electrical sector in the power system and the power electronics like artificial intelligence and IoT. Beyond the power, there are a lot of applications going, lot of applications available. Based on that, they made some research. They are making some research on the IoT also, like home automation, wireless applications, communication network, big data analysis. A lot of applications available. Research also going on. But my major is electrical. That's why I choose the topic. I have idea about the power sector in IoT. What are the applications, IoT application in power sector? That's why topic. I share my view in this session also. First, you know very well what is the basics of IoT. You know very well, all are know what is IoT. Okay. Even though I start just 1 or 2 minutes from the introduction, it will continue process. That's why I will give some introduction about IoT. Ma'am, I'm audible, ma'am?
Yes, sir.
Okay, thank you. What is IoT? The Internet of Things. Okay. What is the basics? The Internet of Things. What is the basic? How it will originate? How it will develop? First of all, the Internet is basics. You know very well. The Internet is basics for the Internet of Things. But Internet of Things for the revolution of Internet of Peoples. You know about the Internet of Peoples. What is Internet of Peoples and what is Internet of Things? First you know the difference, then only we have understand the process. That's it. First, ma'am? Okay, sorry. First, what is internet of people? The people always connected to the internet. People is always connected to the internet. The people share their information to other people. People share their information. Information means just message, any audio message, any video, MMS message, whatever it may be. The information, people share their information to the other people. That is called internet of peoples. So we send the mail through the via internet. We send the mail, official WhatsApp. Lot of things we are using. Okay, for official purpose or environmental application. We are using a lot of them. That is, people share information to the other people. That is the internet of peoples. The second thing, based on that internet of peoples, it is the revolutionary internet of things. What is internet of things? The things or device or instrument share their information to the other instrument. That is called internet of things. First of all, the instrument. There is no human interface between the human to human or human to computer. Only the interference or communication between the instrument to instrument. Okay, the instrument means maybe sensor, actuator, or camera, whatever it may be. That another one the receiver said a lot of camera available, lot of sensor, whatever it may be. Okay. The information shared from one device to or one instrument to another instrument is called internet of things. There is no human interface. Already on the power sectors already developed through the SCADA also. We will discuss in one by one. Okay. What is the difference? Today my title is IoT application in power sector. Okay. Ma'am, my screen is visible, ma'am?
Yes, sir.
Okay, thank you. IoT application power sector. You know already very well. Okay, what is IoT? The Internet of Things describes the network or physical object. Things, that is the things that are embedded with the sensor, softwares, and other technologies for the purpose of connecting and exchanging the data with other devices and systems over the internet. The device or system is connected with the internet to another system or another device is called Internet of Things. Okay. The Internet of Things is a system. I already told the Internet system all interrelated computing device, mechanical and digital machines provided with unique identifier. That is another IP address, that is unique identifier, and the ability to transfer data over network without recurring. Just I mentioned here, without recurring human to human or human to computer interaction. It directly connected with the machine to machine or system to system or device to device or instrument to instrument. That is called IoT. Okay. IoT. Who can connect to the IoT? IoT, you know that who can connect? Any devices or mobile or system, any laptop or tab, whatever, any devices or any microcontroller can connect the IoT. Anybody can connect. Anywhere from the world you can connect. Any business, for analytical business or economical business, whatever it may be, any energy sector, any communication oriented industries or any business, they can use this IoT connect. Any network, anytime, anywhere, anytime you can connect IoT. Okay. This is the basics, you know. Second. This is the basic structure. You know very well about the IoT. Already you know structure about it, but even though I just 1 minute I explain here. The basics. What is this? The 4 part is important. What is sensors? This is the sensor. What you have to measure, what you have to calculate, what you have to monitor, what you have to control. That you need some sensor, you need some actuator. Okay, that is the sensor devices. Okay, the sensor is connected to internet. The sensor is connected to internet via you need some devices that is called gateway or router or any Wi-Fi devices or directly connected to internet. Okay, that is the gateway. One is sensors. That is the primary instrument that to the cloud or internet or any local devices, local internet devices that you need that gateway or any router, any Wi-Fi, that any network connection you must need. Okay, that why after that wireless communication, the data, what you are sending data, that will be stored in cloud server. That is, cloud server means the data, big storage available in the internet. Okay, that is cloud server. Okay, that cloud server, you are what data you are sending, that it will store the cloud server. After the cloud server, it has after the cloud server, it may be the another one purpose. It may be need data analytics. Okay, the big data, the application, they need data analytics. Data analytics means every action. If you use mobile, the big data analytics, they are fetching your data. What you are frequently visiting the video, what you are watching, what you are reading, that already they are listing the big data analytics. I'm full, ma'am. Any interruption, ma'am?
வாய்ஸ் பிரேக் ஆகுதுன்னு சொல்றாங்க.
Sir, can anyone hear?
Sir, am I audible, sir?
Sir, yes, sir.
Yes, audible,
sir.
Okay,
Maybe due to their personal issues, sir.
Okay, thank you.
Someone sent a message.
கார்த்திகேயன் சார்.
Okay, sir. Okay, shall I continue? Okay.
Does anybody having any trouble in hearing? Someone sent message not audible. That's why I'm asking. Is it audible?
Yes, sir. It may be due to their
Okay, sir.
personal
Thank you, sir. Thank you, sir. Thank you, sir.
network issues.
Sorry.
சார்
Okay,
கண்டினியூ
thank you.
பண்ணுங்க.
Oh, okay. The clouds are after the data analytics. The big data analytics already the big data analytics, they made some analytics. But in our electrical or instrumentation and automation also some data analytics, the data acquisition we made. After that, we send the receiver and after that command, what are the action to be taken by using your program. What are the program? You may be microcontroller. What are the processor you need? Based on the processor, what you are program, what are you are already program made in the controller. As per that program, the action will be taken in mobile application or any industries like that. This is the basics IoT structure. Don't waste a lot of time in this basic things. Okay. This is the basic, you know. Now already I told what are the Internet of Peoples and what are Internet of Things. You know very well. They share the information from one people to another people. The Internet of People, they share the information from one device to another. That is the Internet of Things. Okay. Okay. That the main important point here, what I am willing to say here. Okay. Electricity. The electricity is the major changes, major role played before the IoT, before the automation. The electricity is the major role played the important. That's why I mentioned here. The electricity changed nearly everything about the way we live and work. And the scale of transformation is possible with Internet of Things. Already electricity will done all the automation, all the motors, all the mechanical or electrical or hydraulic water equipments, the electrical done successfully in the peaceful manner. But why we need Internet of Things? The scale of transformation, that's the purpose we need the IoT. Okay. What is IoT? IoT is the fourth industrial revolution technology. IoT is the fourth industrial revolution technology. Okay. What is fourth industrial? So before going to fourth industrial, we just know about what are the industrial revolution. Yeah. Because the power supply is the main of the industrial one. That's why we need the first revolution. What is the first revolution? The first revolution is made by mechanical engines, by operating by diesel engine or steam. The steam power or water power, they made the mechanical operating engine. That is the mechanical. The maybe human operated or steam operated or water the hydro operated or any engine. That is the first generation. It is the 17th century. After that, the electricity will develop the 18th century. The mass production, assembly line, electricity. The electricity played a major role in these industries. All the industries are occupied by electricity. Okay, the electricity played an important role. Okay, that is the 18th century. After that, the third generation, that industry is automation. That is the PLC SCADA, like the, in our electrical, the PLC SCADA, the home automation, the automation tools played the important role. That is a huge productivity. First is the basic science, one is the electricity. After the, when we are entering in the computer automation, we are increase the productivity, we are increase the effectiveness also. You know, that is the third generation in the 19th century, and near about 1960, 67. Okay, the last in this century, that is 20th century, we are switching over to the fourth generation industrial revolution, this IoT, that's Internet of Things. This is the cyber physical system, that is the remote locating system. You can operate from anywhere, any devices, anytime. Okay, you no need to be on the plant, you no need to be on with your system. You can play the role, major role from anywhere. That is the fourth generation. Okay, that's why the fourth generation. Okay. Next. What is the fourth generation? What is the concept? In the prior three revolutions, there are tremendous improvement in the productivity. First came the steam and water, next came electricity and assembly, then the computerization. The important point of fourth industrial revolution creates the world in which virtual and physical systems of manufacturing cooperate with each other in the flexible way at the global level. You can, before that, after third generation, you can compete with the national level. Okay, national level means you can compete in the third generation, you can compete at the international, but it is not effectiveness. It was not effectiveness in the particular. But in the fourth industrial revolution, it will mainly useful to beat out the global level market and increase the efficiency. What are the advantages of fourth level? Increase the productivity, okay, increase the efficiency and quality in processes, greater safety for workers, okay, by reducing jobs in dangerous environment, enhanced decision making. That is the difference. Before that, up to third generation, what you are made program through logic diagram, what are ladder diagram, what you are uploaded the program in the automation. That automation play the important role only the automation operation. There is no decision making. Okay, what you are already default program in this. Already you are already default program. Already you are insist the commands. Okay, make the commands within this system. That system is just to follow. Okay. Otherwise, it will give the commands. So this is the system is fault. This is the system. It will happen like that. It will give some information. But it was not able to take decision. But in the fourth revolution, in the industrial fourth revolution, in this IoT, you can take decision making with the machine learning algorithm or artificial intelligence techniques. A lot of techniques. The fourth generation also including not only IoT, the artificial intelligence, robotics. This is a lot of things. One of IoT is the one of the technique in the fourth industrial revolution. Okay. What is Internet of Things? What is the main objective? What happened in the Internet of Things? Only two words. One is operational technology plus information technology. Two things. Okay. If before in electricity in second generation the operational technology is available, but in the automation the information technology is available. We need both effective. We need both decision making that with the operational technology, with the effective operational technology, with effective information technology, with the proper analytical decision making that we need through the Internet of Things. This is the operational technology plus information technology. Efficiency, quality, yield. That I told. The operational technology means normal. It is not operation, normal operation. Efficiency, quality, yield. What you are manufacturer, what you are production. If you are production, you are generating power. The efficiency, quality, yield you need. With less input, you get more output. That is the efficiency, quality, yield. The next one. What is information technology? Revenue, cost, customer service. What is revenue? Revenue is the important one. Okay, without revenue, we are not able to survey our system. Okay. Next, cost. The cost is the important thing. The purchase the customer to buy your product and buy your energy, whatever may be. The cost is important. Next, third is customer service. That it is incorporated the information technology, the best information technology through IoT. Okay. Next, this is the main objective of IoT. Okay. Okay. You can ask one question. Okay, you may arise your questions. Okay. Already the SCADA is available in the market. Already the SCADA available in the market. Already after PLC, DCS, SCADA, all the automation software is available in this market. All the industries are automated by today the 99% of the industries through automation. Okay. The automation is successfully developed and erected and commissioned and maintained perfectly in effective manner. But what is the necessity of IoT? Okay. That is the question you have to arise in your mind. Okay. What is the difference between SCADA and IoT? Already the SCADA is improvement in industries only. That is the improvement in process, improvement in production, improvement in system, improvement in system sequence. Okay. But you can't, the SCADA can't able to take decision. That is the main thing. Okay. But IoT improve the same through automation, predictive analysis. That is the main important point. The predictive analysis. Okay. What is the predictive analysis means? You know, okay, you have power generation. What are the coal available? How much coal available? How much capacity? How much? What is the coal? How much energy produced by the coal? How much coal it will come? How much day it will take? How much energy need? How much energy need after 2 months? How much energy? How much power need after 4 months? That is the predictive analysis. But SCADA, it may not be able to do the predictive analysis, but the IoT can do that. Another one is get a suitable solution. That is the decision making. That get suitable through the artificial intelligence. The IoT, the machine or system or device, they can the decision or solution make alone or autonomously. Okay. That is the main button of SCADA and IoT. Okay. The supervisory, what little bit I will explain here. Supervisory get control data system, the function include the supervision of the PLC. The SCADA is the supervision control, but the program may be PLC. What is the function? Maybe understanding process, analyzing the data. What analyzing the data by human, not the system. Just what is that's the difference between PLC and IoT. That's why I mentioned here. Okay, the both things analyzing data. The PLC also analyzing data, but IoT also analyzing data. But PLC analyzing the data with the human interface. The PLC make the data, the SCADA make a data acquisition system. The SCADA collect the data. If you have a sensor, the SCADA collect all the data about the sensor, but it will not take decision. But human take decision about what is the sensor reading in the first month or second month, what is the motor reading the first month, second month, what is the human take to decision. But in the IoT also analyzing the data as well as take decision. That is the main button. First, the IoT is before IoT, the two things. First is SCADA. SCADA is the first step of IoT. And the second step is the smart meter. Okay, you know very well about the smart metering system. The smart meters are another early example of IoT. The second step of IoT. Okay. With ability to deliver near real-time consumption. But the PLC, the instrument or PLC sensors, normal sensor can give the real-time data. Okay. It gives the approximate data only at 90% of accuracy. But the IoT or smart meters data can give a real-time consumption data provide. Okay. After the smart meter revolution, the IoT, the continuum of IoT maturity, that both solution do monitor and control by itself. Often the operational technology like SCADA and smart meters, both the benefits. That what are the benefits available in the SCADA? What are the benefits available in the smart meter? Both the benefit we can get through IoT. The additional also we can include the decision making also. Okay. Is it clear? I am audible? There is no issue.
Yes, sir.
Okay, thank you. Yes. The IoT technology with the existing character. Can we insert? We can put a IoT for existing of SCADA. What are the benefits we can get? What we can get the benefit? What are the functions? What are the effectiveness available through IoT instead of SCADA? The 8 important points. That's the overall equipment effectiveness. Overall equipment effectiveness. What is overall equipment effectiveness? The one. Because the decision taking. Okay. Once you take decision automatically, the system will reduce the time management. The time management will do the more effectiveness. Once you take the decision, automatically the accident will be minimized. The input means the resource will be minimized. The cost will be minimized. That's why we can get overall equipment effectiveness by taking the autonomous decision. Okay. Second, the machine-to-machine communication. There is no need to human interaction. Yeah. Only the field sensor and your cloud or on your IoT controller. Yeah. The communication between the machine. There is no dependency of your human. Okay. It will not affect. The system will not affected by human error. The system always by machine to machine. There is no necessity to interfere human. That's why the human error will be rectified. Okay. Data acquisition. Already I told that point. The data acquisition already made in the SCADA also. But even though we made in the IoT also the data acquisition, the effective process, because the data acquisition, maybe the system you install in SCADA, the system operated within the plant only. The data maintained in the server system within your plant, within your system. But you can use IoT, you can fetch the data from anywhere, you can handle the data, you can get the data from anywhere, you can get the predictive analysis, all the data get from the IoT to the internet. Okay. The fourth one is security. Okay. The security protocol, a lot of semantic software available for security purpose, but not all in our system also we can break any programs, any malfunction may be occur in this system. But security purpose, the code may be very strong, very secure one. Okay. And the next point is remote management management. I already told the remote management you can, but in SCADA you can operate within your industry, within your control room. You can go to the thermal power station, you have a boiler, operating station. From that boiler operating station, the human, the operator will operate the system locally. But the operator will not be able to operate the system from anywhere. But in IoT, the operator operate the system from anywhere, or the necessity. The system automatically monitor and control the system through internet. Okay. Scalability. What is scalability means? That means the data. What is the cost? What is the resource cost? What is the, if you consider thermal power station, what is the coal cost today? What is the cost after 2 months? What is the coal handling capacity? What is the coal available? How much coal available after 3 months? The scale. What is the range available? What is the productivity increase? How much productivity increase? What is the scalability is easily accessible in the internet office. Next one is cloud assistant. That is also same thing. The cloud assistant in your system. If you are considered, I can give you example in the cloud assistant. If you are now consider the naval thermal power station. In that naval thermal power system, I think approximately 7 to 8 units available. But if the 8 to 7 units available and the operating by individual system, individual operating center. Okay. But you can't operate from any system from anywhere. But the cloud assistant, you can put the cloud assistant, your data, your field data, your instrument data, your program, always stored in your local system only, in our SCADA PLC. But in the cloud assistant, you can access from the internet, you are from the cloud storage. You can access more storage. You can available. You can access the only one control room. You can operate all the power plant. This is the difference between SCADA and IoT. Next one is predictive analysis. Already told the predictive analysis is the main function of the IoT, main advantage, main factor of IoT. What are the next parameters? What is the next 6 months, next 3 months? What is the necessity of the role? What is the quantity need? What is the taken decision? All the analysis we can make to the IoT. Okay, this is the IoT. IoT combined with the advantages of SCADA system. Okay. Now we are entering into the power sector. This is the time we need for that only we can understand this power sector. Take this much of time. Okay. Now the Internet of Things in the power sector. IoT in the power sector. Again, same. What is the introduction? What are the function? Maybe IoT. Simply, data collected from IoT enabled devices increase the productivity and efficiency. We know what is the main objective? Increase the productivity and efficiency. Second point, using IoT, the equipment can be monitored remotely. You can monitor or you can access the device from anywhere. Sensors capture data and send to cloud. Yeah. But the normal SCADA, you can send the data to the system. But here the sensor capture data and send to the cloud. The last point is very important point. The different machine learning and the artificial based algorithm are used in analyzing the data. But before that, SCADA and PLC, okay, we can analyze the data only human, not machine learning, not artificial intelligence, only the machine. But here, the IoT, the main is the analysis made by the machine learning algorithm or artificial based learning. Okay. Drivers. What are the drivers we need in the power plant? Drivers of IoT power plant. What are the drivers we need? First one is low cost of powerful chips. We need what is the low cost of powerful chips? What is Wi-Fi enabled chips? Yeah. What is the necessity? Wi-Fi enabled chips. What you can use any instrument, you can any sensor. Okay. You can access. Okay, because the PLC, another difference in PLC, the PLC is connected through wire, but the IoT is a wireless network. The IoT is a wireless network. You know it well. That's why I have Wi-Fi enabled sensors, different other sensors, meaning temperature sensor, pressure sensor, or humidity sensor. Whatever sensor you can available, you can using into the power plant, you can use as your. These are the low cost powerful chips you need for as a driver. The second one is standardization with IPv6, that is Internet Protocol version 6. The 3G or 4G and 5G network are used. 2G may not be useful. The 3G, 4G and 5G network are used. The devices are standardized with Internet Protocol and IPv6, Internet Protocol version 6 protocol. We need for standardization for the plant operation, plant monitoring, plant technician. Standardization of software technology. What is the technology? What are the software technology for using our system for automation purpose or decision purpose? Use the artificial intelligence algorithm and cloud computing software. Make it easy. You can lot of software available like AI algorithm or cloud computing software. That is deep learning. Lot of available. Okay. What are the benefits of digital power plant? What are the benefits of digital power plant? Increase efficiency. What is smart grid? That is a small power plant, smart grid or smart power plant. Automated devices increase efficiency, reduce the manpower. First thing is reduce the manpower, and second thing is reduce the cost. The automated device no need to money for manpower or fuel or maintenance. Yeah. There is no necessity for manpower. There is no necessity for fuel or maintenance. Okay. Improve the performance. Which performance? Turbines performance improvement and remote monitoring. The turbine performance will be improved, enhance or efficiency improve compared to the SCADA and IoT. The turbine always monitored by IoT, Internet of Things. Okay. Always through the what program you using, artificial intelligence techniques or any machine learning you are using. That's why the turbine performance always improve. Automatically we enhance the turbine performance. We can compare the normal SCADA operated turbine other with the IoT operated turbine. The performance and efficiency definitely improve. Reduce the energy demand. That is the main. That is the predictive analysis. Help to user. That is the main thing. Reduce the energy. Help to user to learn how to use the energy in real time. If you are using IoT technologies in your home, or you are using IoT technologies in your substation, or you are using in your generation station, the users maybe learn how to use the energy in real time. It will handle automatically, give the clear idea, give the clear information to the customer or users. Okay. What is the energy demand? If you are having your fixed small energy meter in your home, it will give the information to the customer. What is the information? What voltage it will go. If you are using it, you can set any point. This is the limiting point. One day you have only 240 watts or 230 watts, at least 1000 watts you can use. The 1000 watts per hour use, the system will give the information to the user or information to the supplier. It will be very communicated one. That is why we can reduce the energy demand. What is the architecture of IoT in concept? First one is edge devices. What are the edge devices? What is edge device? The sensors and gateway. The sensors. What are the sensors you are going to use in the power plant is called sensors. And gateway is the device used to communicate the sensor and IoT hub. Maybe the IoT hub. The second one is the IoT hub. IoT hub is the data hub or event hub or service bus or external data source. You can use the except the edge service or sensor or gateway, all the components will be available or erected in the cloud only. You are not in your local station. The all are inbuilt in the cloud. The IoT hub. Okay, what is your hub? What your protocol? What is the cloud storage? Which ID you can use? That is the IoT hub. Which hub you are using for your application? That is your hub. That is the Internet of Hub. Next, what is your cloud storage? Okay, how much storage you are available? How much storage you are get from the internet? How much storage you get? How much you are get approved from the cloud? That is the storage. That is the SQL database. The storage the store the data in the point of SQL database and block storage or document storage. Yeah, these are the lot of type available. Just I give here I give some of the methods, some of the format. Next, once you send the data from the sensor, that the edge device, and through the gateway you connect to the hub. From your hub, you can store the device in your storage. What you are the cloud allocated for your storage, how much allocated that storage. In that storage, you can store your data as provided already for which format already you framed. That format, based on the format, the data will be stored. After that, the analytics. What are the analytics here? What are the steam analytics? Steam analytics. What is steam? Steam is the important process. We are considered the thermal power station. The steam is the important process. What are the steam analytics? How much steam we need? How much we give the steam force? The turbine, depending upon the turbine speed, how much steam? Before 1 month, what are the steam we are given? If you are given the steam, we can increase the steam. What will happen? Yeah, we can. Lot of questions. What are the lot of analytics going within the analytics? Okay. By using machine learning program or other algorithm, steam analytics. If you are going, if you are installing the wind turbine, the wind analysis. How much wind speed available? How much wind rows or wind density? Which direction available? Okay, you can predict. If you are considering wind station, the wind always available in the one direction. The wind always change the direction. We can that is the predictive analytics. Okay, if you are using IoT, if in the June month you can get the clear idea. Last year in the time the wind get in the direction, so you can get the predictive analytics. That is the main thing of analytics. After the action and presentation, that is what are the apps you are using, what are the notification, you need notification or you need any action. The action presentation means you are the analytics given due to the statement, the next statement based on the analytics, based on the program, it may take action or it may take any notification. Okay. It may take any integration service. Okay. The communication or any integration services. Okay. This is the structure of IoT in the power sector. Components of in the power sector. Okay. Next. Internet of Things in the maturity level. Why I give the name here maturity level? Yeah. Normally we say if you are we are the faculty, you know, or normally say the students also. BA maturity means another. What is the maturity? Maturity means the handling the person having the ability to handling problem, take decision at the proper manner, proper time. That is the maturity. That's why give the name, they are given the name, the Internet of Things, the maturity model. The SCADA is the non-maturity model. The smart meter is the non-maturity model. But the Internet of Things is the maturity model. Yeah, because what are the structure of maturity model here? That in the power sector, that is what are the functions? Monitoring, control, optimization, autonomy, and system autonomy. Okay, this is the 5 major functions played the function. First, the Internet of Things start from the monitoring and control. Through the sensor, the IoT monitor the system. What are the system? The thermal power station or wind power station or solar power generation. The system, all the power stations having the system. System is the sequence process. System is the automation process. That is the system is the sequence process. The sequence process already made by the automation. The automation process is now we are monitoring through the Internet of Things. Okay, by using the sensors. Okay, through the Wi-Fi network. Okay. From the data, from the monitoring, they can get the data. The IoT control the system through the actuator, through the command, through the motor, the control the system. Any commands, any on command, any off command, any limiting command, any valve closing, any valve opening, any temperature control, any whatever that control action. The third one is optimization. Optimization is there, which is the best way to get effective generation of energy. Which is the best way, which is the cost optimization or energy generation optimization. Okay, the optimization process made by the Internet of Things, and then equipment autonomously. That is the way, that is the autonomous. It's already the system running automation in PLC SCADA. But yes, autonomously, what is the difference? Automation is the same process. That is the difference in automation in the autonomous. Okay. You know the autonomous college. Okay. But automation system is different. If you are under the university, you are running examination, if you are running the portal entry, that is the automation process. But the autonomous colleges, they have another take the decision. You have another anonymous power to take question paper, to conduct the examination, to give the results, okay, to change for their current. This is the difference. Like that, the industry also. The SCADA already the autonomous system, automation system, but autonomy, the system taken decision individually, device, that is autonomy. Next is system autonomy. The system autonomy means the system First one is the device or instrument, RAD sensor, any actuator take decision depending upon the input, depending upon the program, depending upon the environmental condition. That is autonomy. The system autonomy is the different, the whole system, the whole thermal power station. If you are considered the boiler temperature, that is the temperature sensor available, the pyrometer available, the pyrometer monitored under control. Okay, that is autonomy. The total boiler operation, the turbine speed, the turbine change the turbine speed depending upon our input. What is the coal capacity? How much coal input? The total system autonomy is the different. This is the structure: monitoring, control, optimization. The which decision we choose. Through the program and the autonomy decision or system decision. That is the function of Internet of Things maturity model. Okay. Is it clear? Am I audible?
Yes, sir. Audible, sir.
Thank you. One second. Example, the entire generation to consumption processing process. What are the entire process? Okay. My screen is visible?
Visible, sir.
Okay, thanks. First, the process controlled by SCADA is difficult. First is the SCADA. Now the SCADA is the process is controlled by SCADA. But compared to IoT, the SCADA is difficult. What is the difficult? The burning fuel. If you are burning fuel in a coal burning fuel, generating steam, generating power using turbine. This is the difficult compared to IoT. Now they are making burning fuel or generating steam SCADA only. Okay. Compared to IoT, this is a little difficult. Until it was costly. Why SCADA is difficult? It was costly. Put enough sensors. They need high cost sensors. Okay. The data should transfer high frequency because the fuel station, the generating station, the boiler have very temperature. The data, the sensing devices are we have to put very strongly under the very costly. That store the large value of data, perform smart analytics of data. Okay, these are the things considered the SCADA. These constraints are being overcome and full digitalization in the process and unleashed by IoT. The IoT is eradicated the full digitalization. The process is the full digitalization. There is no need to cable. Wiring technology. If you are using the temperature sensor through SCADA, you are laying cable. But you are using IoT, there is no necessary cable. So this is the main thing. The generator process can be made flexible by IoT. The generator process is made flexible. But IoT, compared to IoT, SCADA is not flexible because it can support efficient operation at various capacity factors all operating base load mode. This is the main point, the base load mode. What is the base load mode? What is base load? What is the average capacity load? What is the average demand need for the energy demand? That is the base load. You know very well. Okay, but the base load operating there. Okay, what is the difference base load operation and peak load operation? The peak load operation may operate without effectiveness, without efficiency. Am I right? But base load you should operate with effective manner. The system should operate effectively. That is the difference between base load and peak load. But operating base load mode, the IoT is best. The enhance the efficiency. The flexibility is essential to integrating higher amount of renewable power. Renewable also the high power generation, high accurate power, high eradicate power from the renewable energy also, from the wind or solar, especially in wind. Okay. Lot of research completed in the wind through the IoT. Okay. We will discuss that later. Okay. Next point. IoT with advanced analytics can accurately forecast. If you consider solar and wind generation, compared to conventional generation, if you are conventional generator, it is sufficient time to ramp up down, that is reducing emission of power sector. But in solar wind, you can accurately forecast the energy. What are the energy available? What are the wind energy available? What are the thermal energy available in the solar? You can accurately forecast. You can get the more energy. You can get more energy generation through IoT. The next point is advanced metering infrastructure with automated demand response. This is important. Automated metering infrastructure. The smart grid also operating through this technology, that is advanced metering infrastructure. You know very well the advanced metering infrastructure. The advanced metering infrastructure is automated demand response. What are the demand available in the market through the predictive analysis? What are the demand already available? After 3 months, what are the demand response? That may be automated calculated through that advanced metering infrastructure. Because the advanced metering section, the advanced meters always communicate through the proper communication through to the customer or supplier and the generator. That is the advanced metering infrastructure. You know very well. AMI means that the AMI communicate the system, sharing the information to consumer, sharing information to supplier, sharing information to energy generator, supplier, and based on the communication, the customer also making the decision, supplier also making the decision, as well as the energy generation side, they can make a demand response. How much demand going? That is the easiest process. That's why we have the advanced metering infrastructure we use through the IoT technology. Okay. The last one is energy management system. The generator trip ICT. If you are using two port plant here, the generator one generator trip. The ICT or IoT give the data to the GIS or customer information system. How much energy should be bought from neighboring utilities? How much energy demand available? How much energy demand you need? How much already available? How much energy you can bought from neighboring utilities? How much time needed to repair? That is IoT with the detail. How much time needed to repair? How much level of spare part inventory? How much spare? How much cost? Then it will, if your generator trip, if you attain major problem, what are the spare parts you need? What are the spare parts available? Where are the spare parts available? Then the spare parts will come. How much time it will take? How much cost? From that period, how much energy needed to compensate your demand response? How much energy you buy from your neighboring power plant? These are the things the IoT give the brief idea through the energy management system. Okay, this is the main thing. Okay. Next, what are the main solutions? What is the main solution of IoT in the power industry? What are the main solution in the power industry? What are the main? If you are consider just three major problems in the power industry. Yeah, just three problems. That three problems we can eradicate, we can eliminate through the IoT. The first thing is asset performance management. What is asset performance? The asset management is suitable tool for attaining cost optimization, reducing risk, and rendering operation more flexible. What is asset management response? What is asset performance management means? What is the today's scenario? what is your plant capacity, what is your energy demand, what is your resource available, how much resource available, that is asset. How much fund available, how much fuel need, how much resource need for operating after 3 months or after 1 year or 1 year, how much cost need, where the coal available today from GS, yeah, how much coal available, where the coal, where the diesel, what you are using resource for your plant, where it need, okay. Then it will come, what are the cost of resource today, what are the cost of resource after 10 days or after 1 month, after 1 year, okay. We can give the data. This is the asset performance. We can give a lot of things. We can say, continuously we can say the lot of things. This is asset management. But the basic questions, what assets do I have? What assets do I have? What are the capacity? What are the resource? What are the fund? What are the power generation today I need? That's what assets do I have? What, where are they? They are available. Yeah, where it will go? Where we can supply? Where is the demand today? Yeah. What the value do they have? What value do they have? Yeah. What is the cost today cost? What is the economical situation? What is the asset situation? Yeah. What are the mandatory maintenance? Thank you. What are the maintenance action? Mandatory maintenance action should be. Then, where? How much have spent on maintenance? Okay, if you are maintenance, the asset performance, the give the data also, this thing also. If you are having generator, that is the turbine, that is the alternator. If you are maintained after, if you have to schedule the maintenance, that will give the data. How much have spent the maintenance things? After, if you are maintenance, from 1 month, how much cost will it take? After 6 months, how much cost it will take? If you are maintained today, what is the output of the alternator? If you are maintained after 6 months, what are the output? What are the efficiency after 6 months maintenance? That is the very big data. What is the main problem of the asset performance management through SCADA? But IoT gives the major solution about that, the foundation is the asset performance management. These are the things, okay, using asset performance. This is the curve. This is the reactive services. Using SCADA, what are they? It will go down. That is the dangerous. Once a day, the reactive services, we can use the reactive, once it will go the dangerous condition. Yeah. If you are normally, if you are using, consider nowadays the power station like that only. If you consider our neighboring thermal power station, then 1 or 2 sessions, if you use maintenance, it is not able to run. It is not able to run because the poor performance, poor maintenance. But IoT gives another proactive services, another predictive analysis. That is the difference. What is the improper balance, the proper balance? Here expensive, here the service tailored need, predictable, fixed before failure. What is the range? Fixed before failure. If you SCADA, it is not able to give them much efficient, higher reliability, reduced downtime, normal parts of scheduling service. What are the service available? What is the coal handling done? What is the ash handling? When we have to service? What are the capacity of ash? What is the capacity of coal? Okay, that is the service. Okay, what is the boiler capacity? What is the boiler temperature here? When we have to service the boiler? What is the turbine? What is the capacity? Lot of proactive. That is means the asset performance will give the proactive services. That is called proactive services. Okay. These are the disadvantages in the previous system. Existing systems like another expensive, unpredictable. Something will break. Customer must divine good. Extend downtime. Rush part of order. These are the but proper balance through the IoT, through the asset performance management system. By using IoT, we can get managed. We can from here to top. The curve is the total inverse. Okay, you can understand. Okay, you can understand. Okay. Next. The first one is asset performance management, and second point is operational optimization. The power plant in the grid have to meet Standard requirements for frequency control. That is the main important of. That is the alternator and alternator coupled with alternator. That is the frequency control, voltage control, dispatch control, automation generator control, and RAM rate. This is the main optimization need for the alternator. You know very well. But this may be perfectly optimized through IQ. You can get the operational optimization, good operational optimization through the IoT. The third one is the important point: comprehensive customer services and experiences. Comprehensive customer services and experiences. What is this comprehensive customer? The main thing is, what is that? Means the customer service that cover every aspect of customer need. What is this? Cover every aspect. What is the energy demand, the continuous supply, tariff, any integration, any if they are using any solar power plant, they have to integrate with our grid. Any communication, any billing, any pre-predictive awareness, total satisfaction. That is the comprehensive customer service and experience. That should be made perfectly done by our IoT. That is the portal of customer. What is the portal available? That is one is what the customer need. First important, manage usage. What they are using. But normally in our electricity, in our meter, we are not able to see the usage. We have to use it manually. But manage. We can see the usage, but we are not able to manage the usage. But through the IoT, artificial, that is advanced metering section, the manage usage also. You can set the point. Per day, I can use only 1000 watts per hour per day. Here, energy. That will be managed automatically. That is the another AMA. Next, billing. Pre-billing system or post-billing system. And other customer support issues. Next, net metering, sell power to grid. Already told net metering, sell power to the grid, or prepaid purchase of electricity. These are the things used in the ANA. In addition to energy usage, smart meter can also line voltage information, which is used to maintain disturbance of voltage reduces loss. Because you can use the application with low voltage, definitely it causes the losses. The losses convert to the reduce the power factor. The overall power factor will be reduced. The overall efficiency of the system will be passed. That may be cause of low voltage information. Give the information also. This is the main three things. Give the major solution to IoT. That first one is access management system. The second one is operational optimization. The third one is comprehensive customer service experience. This is the main thing. Next one is, what are the communication network used in the smart power plant? Means IoT power plant. This communication network. What are the networks available? One is home area network, that is covering home IoT devices, wireless, Zigbee, that is the home area network. The second one is neighborhood area network, that is MAN, distribution domain network, data captured from smart devices and send gateways. That from home network you can get the data only with your home automation, with your home only. There is no contact with the internet. But neighborhood area, it will be connected to the internet, that is there through gateway. The second one is field area network, the distribution system, regulator, controller for your distribution area, that is a field area, that is fan. Finally, the conventional network, the wide area network, that is there. Fan, wide area network. This is the core network we can use in the smart power plant. What are the types that we can use? We can explain. I will explain here. This is the information flow and power flow and power system. If using WAN, that is another wide area network, in the generation station. In the generation station, wide area network needed because the generation station must know the detail about the energy demand. That is the energy demand of the system, energy generation of the system, what are the total energy, where we have to share, what are the local available, what are the conditions available, that generation station, that is a wide area network. It is a step up transformer. Depending upon the generation, give the step up voltage. We can change the tap up, okay, tap up the transformer. Next, NAN. Okay, that is another neighborhood area network. That is transmission side. Yeah, that is the neighborhood network used in the transmission network. That is the step down transformer. Our system is the step down transformer. Okay. The third one is HAN. That's the home area network. The home area network is distribution and consumption. That is the gateway. If you are there in your distribution side, what are the power available? What are the power get from your generation transmission station? Okay, you can how to energy send to your customer. How much energy sent to the customer? How much duration? If you have any power demand, you have to circulate the power from one area to another area. That is there. That is the power system operation. Okay, that power made by the hand. Home area network. Okay, next. These are the network available. Next. What are the applications available in the power plant? One is digital twins. What is the digital twins means? Consider as a virtual power plant. It may be considered as a virtual power plant. Okay, virtual means you can now like the virtual classes. You can operate from anywhere. Okay, virtual online you can take the class to the student from one place to another place. But like that you can operate from one place to another place. That is the virtual power plant. Reduce the fuel and the energy consumption. That is the energy consumption. Okay, by incorporating data. That is main thing. That is the incorporating data. Next one is supply chain management. That is the main application. That is means sensor monitor product condition, optimize delivery time. Means sensor monitor the generation, transmission, and the distribution. That is the product condition. What is the optimization? What are the available? How much time the energy consume? How much energy we need? How much time you can deliver to the customer? That is the supply chain from the generation station to consumer. Okay. Next, smart pumping combined with the sensor and software, automated flow control. That is smart pumping. Automated flow control means the pumping. If you are using diesel sensor, if you are using diesel system, if you are using pumping steam, that time you have used a sensor and software for automated flow control. For depending upon their operation, depending upon your turbine generation, turbine speed and generation, you can get here. Next one is smart boiler. The main thing is smart. What is smart boiler? Normally you know the boiler, but what is smart boiler? Customer can control by mobile application. You can by mobile application. You can easily control the smart boiler. But today by SCADA it is very difficult one. But you can. That's why I told. Already told that point. The SCADA is little bit difficult compared to IoT. But customer can control by mobile application. Energy efficient usage. Yeah, but normal boiler can't have energy efficient. But automatically reports if any defects are there. Automatically reports if any problems are there. Automatically reports there. But in SCADA, it will show the indication. What fault? What are the problems occurred in the system? We have to find through the human interference. Okay, the SCADA will say this is the system. The system is stopped. This system is stopped due to overheat. But the human go and interface with what is the reason to increase the temperature. What are the reasons behind that? They has to know start of the problem. But in IoT, automatically report if any difficult or there, automatically give the solution, automatically take decision. If this system may not take decision, the report may, at least report may be here. This is the problem. This is the reason. This is the this is may not able to rectify. Kindly rectify. Lot of detailed report can get from smart boiler. Okay. Smart water monitoring means the cooler side, that is the water pumping or the producing steam. Different flow watt meter, volume water, pipe time period, send data to cloud storage, how much water need, how much temperature, If now normally you know about the power plant operation, okay, that the water continuously so the steam after the steam will cool, the water recycle. Okay, this is the process. But in IoT, we are not controlled. We can't control. We are not sorry. We are not. We can control the input. We can control the input water. How much steam already available? How much water needed to maintain that steam temperature? How much need the steam pressure? Yeah, that we can get predict data. Next step. Save wastage water. Okay, wait, what is that? Next one is smart metering. You know very well what is smart metering. Important element of smart metering. This is already told. Reduce the operational cost and reduce the chances. Already a lot of things we discussed in the smart metering. Last one is building automation means the if you have any power station, the building available for operating station like that, the elevator, lighting system, and other those what are the electronics available in the connect to the internet, we can easily control. Yeah. Next. What is advanced metering infrastructure? Yeah. In advanced, this is the important thing in IoT. What is advanced metering infrastructure? It comprises whole infrastructure in smart meter with combination network. Smart meter in the combination network. Smart meter. What is smart meter? Collect information about energy, water, etc. Transmit data to the network. That is the smart meters. Okay, we will discuss smart meter in next slide. What is community network? Broadband over power line, fixed radio frequency are used. This is the communication network. Meter data system. Gather data from smart meters. Meter data management system. That is analysis data. These four things is combined is called advanced meter infrastructure. That is the main part of IoT. The main part of IoT. Okay, this is the four things. In this case, what is smart meter? You know, smart metering system. This is the smart metering system. This is the symbolic black diagram for I put here for understanding purpose. This is the smart metering system. What is the power marker? The smart meter give or share the information to the consumer and the power supplier and the power distribution and the power market and the power producer and the energy regulatory authority. Yeah, the one system, see the smart metering system. One system send the detail, all of this. That is the cloud network. That is we can get all of us gather the data. Now you can get the data. If any single data get from single meter, they can get the data to the power supplier. If you consider the Kumbakonam unit, consider like a Kumbakonam unit or Tamil Nadu unit, the power supplier gathering data, and the power distributor gathering data through the smart metering. Power market, the power market contains all the power units, or government sector, private sector, thermal power plant, nuclear power plant. What are the total power market available in India, in Asia? That is the combination. Next, power producer. Those who are, what are the power producer? Where the power producer and the power supplier and the energy regulatory authority. Those who are regulating energy authority. The single meter. That is the smart metering system. This is the part of IoT. Okay. I think you can understand. Okay. This is the finally. What is the IoT application in wind energy? In wind energy sector, large turbines are used because every fan having the individual turbine, individual generator. It is not at all the remote position. Yeah. The factories are located at the remote location because the remote location only having the wind. Okay, it is hard to maintain because normally wind system is the maintained wind guard because we erected one tower. Yeah. With IoT, the local control system can adjust switches and software. You can control the system from your city, from your home. You can access from the plan from your local location. The remote location of form is not issued with IoT, but in SCADA IoT is the problem. Yeah. But IoT can predict any issues of turbine easily, and it can be addressed earlier before large scale damage. Yeah, that is the main thing. But SCADA give the information. Once it is give the information, it is damaged. But IoT give the information before the system damage. That is the main difference between SCADA and IoT. The large scale damage, we can predict, we can turbine maintain easily, we can predict the problems easily. Yeah. In IoT solar energy applications, the IoT based solar sector sensor monitor the performance of control panel, gather data, send the cloud analysis. IoT help to understand the problem of device, whether it is hardware related problem or network related problem. IoT help to detect any problem in real time. IoT can large solar grids. If you are producing large solar power plant connected to the grid, IoT can manage through the smart grid or microgrid or distributed generation. IoT playing major role in the distributed generation or microgrid or smart grid. Okay, the IoT. Okay. Challenges. Okay. If now we are up to this discussing the what are the advantages, what are the applications, what are the main functions of IoT, what is the importance, what is the things that we discuss. But what are the challenges available in IoT? First one is security issues. Privacy issue, chances to deny of service network. If you are having network, if you are having any problem in Geo, the system will collapse. If you have any service in other problem, that is a network problem will arise in the security issues. And the low power devices, because the IoT devices are always in low power devices, that we have to maintain battery properly. The next one is scalability issues. Because number of devices are increasing, the increasing data bandwidth. Because that data is connected to the cloud. That's why there is scalability issue. Because number of devices you are going to increase, the increasing data bandwidth also increase. That is the main issue. The determination of network using cloud make the process delay, because the cloud directly connected to the cloud, because the SCADA is connected to the local station, but the IoT is connected to the cloud station. The cloud, you are using the connect to the cloud, it may be 200 millisecond delay or more, it may be big. That is the delay of your function. Okay. This is the challenges in IoT portfolio. The two applications I would like to say here, the two applications. First one is the finally. Okay, the first one is Internet of Things for flame monitoring for system boiler. If you are using boiler, that flame is the important, because flame we have to monitor the flame. Depending upon the flame image, we can feed the coal, or we can feed this diesel, we can feed the gas, water maybe. The boiler we need. What is the research made by this session? That is in this topic, the Internet of Flame Monitoring Power Station Boiler. The 51 flame images are used to train 51 flame images. Come back. Okay, to take train and test the model. Based on the experiment, 51 flame images, the classification of flame images based on combustion quality. That is, the pressure quality is dependent upon the flame temperature and color. The solution includes the Internet of Things. But in SCADA, we may not have any time like this. Sure. We have flame detector. In SCADA, we have flame detector. We have flame detector, we can by human flame detector detect the flame and give the signal to the SCADA. In their operating station, the operator see the flame. Depending on the flame image, they give the fire to the boiler. But in IoT, the maximum in the preset, the 51 flame images, different time, different. Depending upon the flame image, the IoT give the feed to the boiler. IoT give the feed. That is the fire feed to the boiler. As a result, the intelligent system can be developed to the monitor and control air-fuel ratio. That is, air-fuel ratio means that is the combustion quality is also minimized that by reducing air pollution. What is the object of this research? If you are unwanted, if you are given unwanted feed to the coal, feed to the fire, the excess air, the excess carbon emission will be less. But using IoT, there is no, you can totally minimize the carbon emission. Yeah, that is we can minimize the air pollution. This is one of the research, that is the IoT flame monitoring power station boiler. Another one is wind resource assessment using IoT. That is the wind resource assessment. If you are using wind power station, what are the parameters, what are the predictive analysis, what are the optimization we can use by our IoT. One is wind speed. We can predict what are the wind speed today, what are the wind speed yesterday, how much wind will available after 2 hours, we can predict. Monthly average wind speed, that is the main thing. Monthly average wind speed available in the IoT, predictive analysis. Wind loss. Next, wind speed distribution. Wind speed distribution and turbulence intensity. That is turbulence intensity. Yeah. Reliability assessment. These are the things we can manage through what? Yeah. Okay. Thank you. Thank you for opportunity given here for last 1.5 hours. Sincere thanks to our participants. Your lot of passion here. My technical view. Thank you. If you have any queries, kindly ask me.
Thank you, sir.
Good morning, sir. Am I audible, sir?
Yes, sir.
Sir, can you brief about windrows, sir? The previous slide you have specified applications of IoT windrows.
Sir?
Yes, sir. Can you brief about that application, windrows?
Just a minute. What is wind rows means that total wind structure. I will do image just a minute. Sorry, I'm not able to explain, but I will explain. What is wind rows means? What is the wind meter per second? How much height? That is the wind total blade will be circulating. That is the blade will be circulating the wind height. The wind strike. What is the height? Depending upon the height, we can give the force. That is the wind rows. Is it clear, sir? We can predict how much, which month we can get which height, which when the wind oppose the middle of the blade or down. If we get the down of the blade, we are not able to put another. We get the speed. We are not able to get full speed. Yeah, that is the wind rows.
Thank you, sir.
Thank you so much, sir. Really, you explained very well. Once again, thank you very much for giving your valuable timing for us, sir. Thank you. Once again, I thank you to all for your kind cooperation and patient listening. Any queries, participants? Okay, thank you.
Okay, ma'am.
Participants,
Thank you.
okay, thank you, sir. Participants, the feedback link will be sent in the chat box and also in the WhatsApp group. Thank you. Shall we end the session, sir?
Thank you, ma'am. Okay, thank you.
Okay, thank you, sir.